Hi everyone and welcome to my channel. I've been waiting for half of a year to get the cells for my RS high current battery project. So right now I will show you how am I going to assemble this wheel, but firstly I would like to start my tuning with the controller board. This is an old school Begode green controller board which have absolutely no limits, and since this is a unique board right now and you are not able to buy it anymore, and since this is a really unique board, you are not able to buy it anymore, only just on used market. If you are really lucky you can find it. So I'd like to make its life as long as possible, and considering another fact that right now I have a really powerful high current battery which will supply this little beast which huge amount of current, I would like to significantly improve cooling system of this controller board. So I'm going to remove the controller compound, get rid of the stock shitty thermal pad, replace it with the ceramic pads and cover it up again. This procedure will significantly improve the controller board MOSFET's cooling and I believe extend this controller board lifetime. So I finished removing the compound from the controller board at required places where the bolts are located, and also I removed the controller board from the heatsink. I must say that it is not a complicated procedure. It took me just 25 minutes to do that, but since I've done that for the first time, I can consider that the next time it will be much faster when you will have more experience with that. So I must say that there will be no problem for repairing of this controller board, just in case if some elements on it will require replacement. But I must warn you that you should never use the tools like this screwdriver, because you can damage the SMD components soldered on this board, or maybe you can damage traces. All you can use is these wooden sticks just to clear up necessary parts of the controller board from the compound. Then after you have removed all the screws, you can gently pull up the controller board using wooden sticks like this, not bending it so hard, and gently remove it from the heatsink. What I would like to show you guys here is how the top level hydro protection of the controller board looks like. You see that compound went here for quite a big distance inside, so here it is protected very well. As well from this side, you've seen I've removed a lot of compound from here, and that side was installed right to the DC-DC board, and you might see here that there is no place for water from this side. So this controller's board MOSFETs area was very well sealed. And also I would like to show you the problem I found on this controller board. You may notice here a big drop of solder on this transistor leg, and if you take this shitty thermal pad, put it like this here, we can see that there was a hole. So if I take my stick, it just goes inside, and what this fucking drop did, it just short-circuited the leg of this transistor to this heatsink, and that is a real big potential problem for future, because if something will happen and some other component will short-circuit on this heatsink as well, like for example some of the transistors or something on the DC-DC board, this controller board would burn up, and the result will be very harmful for the rider if it will happen on the high-speed riding. By the way, this is Begode RS high speed. So you may see here, this is C30 version. So right now I am going to remove this fucking drop with my soldering iron, clean up the heatsink, clean up the MOSFETs, remove all unnecessary compound here, install this controller board on ceramic thermal pads and put it back on the heatsink, and of course cover it up with the compound again. Finally, I've welded my battery, and right now I want to do the real quick review how it is made and what it consists from. So the core of my battery will be high current cells, which are Moly cell P42A. You can browse datasheets if you are interested in Google. The shape of this battery is similar to the Begode or Gateway stock one, you can see. The main idea of doing so is that it fits standard battery places of RS or M Super Pro. The shape is achieved with these holders, which are custom printed on the 3D printer. The author of the model is Lev. I will leave the link to his nickname in Telegram in the description to this video. So if you want to do the same custom projects as me, feel free to contact him and order your set of holders. Also, I have a custom chassis board here. The author of this chassis board is Ibalit, and I will also put his Telegram nickname in the description to this video. It looks like a stock BMS of Gateway, but it is not really a BMS because it has absolutely no logic. All it has here is just soldering places and the traces inside of this board. One may ask what is the purpose of doing batteries with this board, and now I'm going to explain that. To explain that, let's have a closer look on the battery I have already made. The main problem which solves this chassis board is that you are getting rid of the mess of the balancing wires which are coming across all of your battery assembly. And of course, if you have ever done a custom battery assembly, you have to think of the balancing wires, how to place them, how to protect them from being damaged and short-circuiting, and so on and so forth. This is a really pain in the ass, and with this board, all you have to do is you solder the balancing metal strips on its places, and then you have to solder the balancing wires from the BMS right here on these contacts of this board. And that's how you make sure that your battery is very well protected and rock solid. Another great advantage of this board is that when you solder these balancing metal strips to its places, it gives the battery pack solidity, so it's now really rock solid, and it protects the parts of the battery assembly from moving along each other. And another great advantage comes here as well. Since this chassis board is pretty thick, it gives additional protection to the whole battery packs, because you know that in RS or M Super Pro there is a plastic cover on the battery on this side, and when you have a crash of your EUC and something goes wrong and your EUC gives a strike with some sharp object into the battery cover, there is a real big risk of damaging the battery pack, and it may even burn. So this chassis board gives additional protection here and does something like armoring of your battery pack from the side of the cover. You may notice that this chassis board has been developed for 24S2P configuration, but I've done it a little bit different. If you take a closer look here, you can see that there are no balancing metal strips here and here on these places. That's because I've done a little bit different config of my battery pack. It has been welded in 12S4P configuration, and I will have two battery packs which will be connected in series, resulting in 24S4P configuration. This is done intentionally because I do not want to mess with two extra BMS like in stock variant from Begode to control each battery pack. So I plan to make a big battery consist of two parts connected in series, which will be controlled just with one BMS. This is a little bit more complicated than having two battery packs with separate BMS, but this will give me really easy usage in the future, because I do not have to connect to two different BMS to know what's the status of my battery pack is right now. So now I'm going to solder the power wires, the balancing wires, to cover it up into the shrinkable tape and put it right into the EUC, do all the wiring, and then I'm going to show you how it looks like in EUC and how it is going to work in future. Finally, I have assembled everything like it should be, and now I'm gonna show you guys how it is done and how it will be working. So first of all, I want to talk about the ventilator improvements here. I believe that owners of RS version 2 know that this ventilator fixation really sucks. It kinda installed here, but it has a really shitty fixation here from the factory. What Begode does, they just pour some sealant here and then put the ventilator on it, so using it kinda like a glue. So what I've done here, I have made some kind of chassis for the ventilator from the polymorph plastic, and now the ventilator is being installed here tightly and nicely, like going into its place. And you may see while I'm trying to move it a little bit, it doesn't move anyway. So when I will put here an external cover, it will push on this foam material and push this ventilator into its place nicely and tightly, and I will be sure that nothing will happen here with the ventilator while it will be working, and it will not run away from its place and will damage something here. The next part here is the installation of custom LED strips on the bottom of the inner shell, in this place and in this place as well. So they are buried inside of these areas with the epoxy resin. So the purpose of this tuning is to light up the surface under the wheel and also light up the motor of the wheel. I think it will look really cool during night time. To power up all these custom LED strips, I am using the custom DC-DC converter here, which takes power straight from the battery. Right near to this DC-DC converter there is an SSD relay which takes up the power up signal from the controller board. Every time I will turn on my wheel, the SSD relay will power up my DC-DC converter directly from the battery, and the DC-DC converter will provide power to my custom LED strips on the bottom of my wheel. All the cabling, which includes the power line, the balancing wires, the auxiliary power wires for the DC-DC converter, is done right here, like Begode style, which goes on the other side. And right now I'm gonna flip my wheel and show you what's on the other side. This is how it looks like from the other side. Here is my BMS. This is ANT BMS. It is already covered with the special compound to protect it from water ingress. All the power wires are here on this side of this wheel, so there is no power connection coming through the BMS. Although I really like the protection capabilities of the smart BMS, I had some problems with my previous project, MCM5, which I was running during the winter, and I caught some bugs when my wheel would cut out due to BMS problems. So I've made the decision to bypass the power connection from the BMS to make sure that nothing bad will happen during the riding of this wheel, because this is a really fast and powerful wheel, and although the MCM5 runs just 40 kilometers per hour, which is safe speed for the MCM5, this wheel can do much more. And you know, the risk of hurting myself during cutout is also much bigger than on that wheel. And the burnt controller board will be definitely much more cheaper than going to the hospital. The balancing wires are right here. You can see that part of the balancing wires are coming to this battery pack. The other part is going to the other pack. I might remind you that this is not like Begode does separate packs. These two packs includes in one big battery. Each pack is just 12S and 4P configuration, and connection in series results in 24S 4P config. And this was done intentionally by me to get the benefit of monitoring the whole system with just one BMS. So here we have 16 AVG connection from battery plus for power supply of auxiliary systems here, like my custom LED lights, and here I do have a fuse. Although the ANT BMS has really good capabilities of short circuit protection, I would like to have another level of safety for my system. Here is the battery minus, which comes inside the BMS. Also, this battery plus and charge minus from the smart BMS goes directly to the charge port of the wheel. This is the connector for the DC-DC converter, which powers up my custom LED strips in the bottom of this wheel. Here you can see two extra wires which are coming into the battery assembly from the front of it. They are used to connect thermal sensors inside this battery assembly. Each battery assembly includes two thermal sensors, so the temperature of whole battery assembly is being monitored by this BMS. Also, I have installed extra custom button to wake up this BMS. This is really useful when your wheel is installed into stand and you want to see what's with your battery, what is your charge level, and you can come up, push it down and connect with your smartphone and see what's happening, what is the energy level, what is the temperature, and so on and so forth, whether you need to charge up or you are ready to ride. And you do not need to take it out from the stand and power it up and connect your wheel lock and see what's happening. Since this is the smart BMS, it includes a lot of parameters, so you can set up, for example, if your battery pack reaches lower than 0 degrees centigrade or whatever your data sheet for your cells says, you can forbid charging, for example. And if you will come inside your home from the cold weather and try to connect the charger, the BMS won't charge the battery until they reach, for example, this temperature. This gives a lot of safety, reliability and lifetime for the whole battery packs, because with this BMS you can keep them inside the datasheet recommended parameters. Finally, I have assembled my RS, and now it's time for some conclusions on the tuning that I have done. This is the first and unique RS version 2, which is powered by high current battery, which is managed by smart BMS. And in my opinion, this is how wheels should be done from the factory, but unfortunately it's not right now like this. And I believe, unfortunately, we will not be able to purchase such wheels out of the box in nearest future. Here in this exact EUC, we have everything we like so much from Gateway. This is the green controller board, which has absolutely no limitations and runs like a hell. There is a high power battery which powers up this controller board and the motor. And to compare it with the stock one, so the stock battery with M50T shitty elements could produce just 40 amps of continuous current, and this one moly cell battery can produce up to 180 continuous current of amps, and this is a really huge powerful upgrade to this wheel. And I believe that this wheel with this battery will surprise me with the exceptional performance in comparison with the stock one. Additionally, there has been installed a tuning kit from EUCU. The link to EUCU Instagram is in the description to this video. Check it out. There is a lot of tuning accessories for your Begode and Gateway wheels of premium quality. So we have here the pedal hangers with 20mm lift. There is a custom pedals from EUCU with lots of spikes here. There is a custom fiberglass shell to protect the wheel during the crash, and custom jump pads called muscles. All these accessories can be found in the EUCU Instagram and of course ordered for your wheel. One may ask me, why haven't you added more battery packs, because you have a lot of space inside the wheel. For example, you have removed the speakers, or you can remove the BMS. To answer this question, I must say that there is only a small bunch of people in EUC community understands what high current batteries mean. For example, in this case of the stock battery of this RS, formally it states 1800 watt-hour battery, but practically you are not able to use them all. So when this wheel reached about 30% of charge, I was not able to run it like Begode style. I had to run it smoothly, like it was not a powerful wheel or some weak wheel. And frankly speaking, my understanding was that I was able to use just 1500 or 1600 watt-hours in the Gateway style. And speaking about this battery, it has capacity of 1600 watt-hours. And since it's a high current battery pack, it will give the lowest voltage seg up to the very end. And I will be able to run the CUC with the mileage as the stock one, but all in the Begode style. The next thing, I do really hate heavy wheels. I don't like the new wheels which are coming right now to the market. I think if the wheel weight is about 50 kilos, I don't like that, and I'd rather choose the motorcycle than EUC. In my opinion, the EUC should be lightweight and as powerful as possible. And when I started this project, my goal was to make as lightweight and as powerful EUC as possible. And I think it was successfully accomplished. So that's about it. If you like this type of tuning, leave a like, comment this video, subscribe to the channel. See you later, guys.